Hello, and welcome to our FEDD presentation. We are the Brush Bros. I'm Jacob.
I'm Shruti.
I'm Dylan.
And I'm Emily.
In this presentation, we will be walking you through the 10 steps of our engineering design cycle that we implemented for our FEDD project. The first step was to identify a need. Our goal was to build an assistive device that could help someone with a disability. We decided to choose arthritis because it was widespread and there are currently many different issues that need to be solved dealing with it. We then had to assemble our team, which was conveniently already chosen for us by Sahaj. Our 4 members and their roles are Dylan, who was in charge of gathering materials, me, Jacob, the lead designer, Emily, the document manager and team communicator, and Shruti, the 3D modeler. We picked these roles based on our respective strengths and experiences. We then had to identify the constraints and criteria for our project. These were that we had to design a project for a disability which could occur in humans or animals, that costed under $40 to make, and we also had a time constraint for the project. The project had to be completed by the deadline of November 26th.
The next step was to search for possible common problems associated with arthritis and then come up with solutions to them. The 4 main problems that we researched about people with arthritis were that they had trouble opening things such as doors and jars, that it's hard for them to write or type, that they had problems brushing their teeth, and that they have trouble properly tying ties. We then decided to split up these problems among the members so that each person could research and analyze potential solutions for their problem. The solutions that each person came up with was an arthritic toothbrush, pen, jar opener, and an automatic tie tire. After presenting our ideas to the group, we voted on the best solution as a team. We decided to go with the arthritic toothbrush because the current toothbrushes marketed for people with arthritis were not effectively designed, and we felt that we could create something better. The next step was to document our solutions in our very own design notebooks. These notebooks were filled with unique designs and sketches, research, statistics, and measurements. To communicate our solutions, we shared our design ideas with each other and discussed the pros and cons of each design. After careful review of each design, we picked the best one and got to work creating a prototype. The prototype would consist of 4 parts: the head of the toothbrush, the bendable stem, the hand plate, and the connector piece that held the hand plate and stem together.
We had to make each piece out of affordable and readily available materials. The head of the toothbrush would be created by removing the tip of a normal toothbrush. The stem was created by using a hot glue stick that would then be glued onto the head. We decided to use a hot glue stick because of its flexibility and stability. The connector piece and hand plate was made by modeling it on the computer and then 3D printing them out. To make the plate able to stay on the hand, we attached 2 elastic bands onto it and sewed them together. We attached all the pieces together to create our final product. After the first prototype, we realized that there were some flaws. First of all, our 3D printed connector piece initially came out deformed due to the limitations of the model that we designed. In order to fix this, we reprinted and subsequently machined the parts to specification. Another problem we encountered was our original intent to make the bendable portion of the brush out of low-density polyethylene for flexibility. Due to the non-workable nature of commonly available forms of this plastic, the hot glue stick was used in its place in the final prototype. Finally, the diameter of the holes in the plate were too small in the initial print. To fix this issue, we drilled the holes to a diameter just large enough to let the connector piece snap into place, as originally intended.
And as you can see, this is our final product, the bendy brush. And now for our reflection. Unfortunately, we were not able to place at the FEDD competition, but we did have a great time communicating and demonstrating how our product worked to many different people. We decided that if we were to change one thing about our project, it would be that we would begin the construction process sooner as to effectively utilize all of the time that was made available to us. Finally, if we were able to give advice to future students, it would be to figure out what you are going to do for your project early in the semester, and don't wait until the last minute to start construction on your project, and remember to think outside of the box. Thank you for listening. This is the Brush Bros signing off.